This is A21 Physics 4. It used to be an A21 Physics 4, it's now on AS1. January 2009, and this is question 1, and it's about strain energy, Hooke's law and Young modulus. Figure 1.1 shows a cylindrical metal rod clamped firmly at the left-hand end. The rod is of original length L and cross-sectional area A. The application of the longitudinal force F causes the rod to extend by a distance x or extension x. The Young modulus of the material is defined as the equation stress over strain. Write down expressions for the stress and the strain in terms of the quantities defined above. So that's just you writing down your definitions in terms of equations. So sigma is force over area, so it's F divided by A. And strain is extension, which is the x over length. So force over area is stress, strain is extension over length. Part B of the question. Describe a school lab's experiment to determine the Young modulus of a copper wire. Structure your answer under the following headings: label diagram of experimental arrangement, experimental procedure and processing of results. So this is a diagram that you must learn, and I'm going back to our diagram that we have in the front cover of your booklet. And so you have something drawn there where you show a support, 2 wires, one of them's a reference wire and the second's a test wire, just scanning a wee bit. You can see down on the bottom third of the wire you've got a vernier scale, and you have a reference scale opposite that on the test wire. A weight on the reference wire to keep it tight, nice and tight, and then your load is going to be placed on the test wire. And the last thing there that I marked in the last time I marked in the actual original length of your wire. I'll just scan out so you can see that properly. See the length of your wires between where it's on the support and the bottom of the top of the vernier scale. Okay, so whenever you explain that, and again, this is really worth your while learning that. So your procedure, you've got 5 marks. It's an awful lot of marks for something if you don't know it that well. So to calculate these, there's actually about 8 marks they've given in the mark scheme, and they're giving you any 5. So first of all, you need to measure the original length from the support the vernier scale, and you're using a ruler. So always say what you are actually using. Second point, measure diameter of the wire. Using micrometer screw gauge. And then you're saying that you're going to calculate the area of the wire by doing pi d over 2 squared. Now you're going to repeat d 3 times and use average to calculate A. You're going to change the load and record values for load versus extension. Measured extension. And you're using the vernier to do that. And then you're going to repeat and check each time. Wire goes back to original length. Now you could go on to describe the graphs that you're going to draw here, but it asks you over the page how you process the results. There's 5 marks for the description, and if we look over the page, 3 marks for the processing of the results. So that's what graph do you draw and what do you calculate. So the marks here, measure the length, gives you 1 mark, and always say what you're using to measure it. Measure the diameter of the wire, with 3 places to get an average and calculate A. So if you're going to repeat it and calculate A, change the load and measure extension for each load. That's 5 there now. And then repeat. And that would give you a 6th mark there. And it's only 5 out of 6. Now what you actually do with that then, of course, is you're going to plot a graph of, so A is equal to sigma over extension, which is force over area divided by extension over length. So you're going to plot a graph. If you have a wee look at that and rearrange it, F over A is equal to E times extension over length. And if we write Y equals mx underneath that, you can see you're going to plot a graph of F over A on the y-axis versus x over L on the x-axis. And then the gradient of your graph is equal to E, which is that Young modulus that you need to calculate. And that gets you your mark. You could also say that that's a straight line through the origin, stress over strain.